Welcome to Practical Statistics for Nursing using SPSS. This video shows how to process the ANOVA test. You can watch the entire video or use the time slider to navigate directly to any time point. The ANOVA test is similar to the t-test, but whereas the t-test compares two groups of continuous variables to determine if one group statistically significantly outperformed the other, the ANOVA test can process three or more groups. In this example, we have three groups. The members of each group will be given an antihypertensive drug. The participants in Group 1 get drug A, the participants in Group 2 get drug B, and the participants in Group 3 get drug C. After a month, we'll record the systolic blood pressure of each participant. Group 1 had a mean of 120.37, Group 2 had a mean of 122.37, and Group 3 had a mean of 122.70. The ANOVA test will compare the groups to each other and calculate a p-value for each pair of groups. If the p-value is less than or equal to 0.05, we would conclude that one drug statistically significantly outperformed the other. This example uses the dataset CH06 example 01 ANOVA.SAV. This dataset contains two variables. The first variable is group, which is a categorical variable containing three values. Group 1 gets drug A, Group 2 gets drug B, and Group 3 gets drug C. The second variable is systolic BP. This is a continuous variable that contains the systolic blood pressure reading of each participant. The ANOVA test will compute the mean for each group and then calculate the p-value for each pair of groups, which will tell us which group statistically significantly outperformed which. The ANOVA test has three pre-test criteria: normality, N-quota, and homogeneity of variance. We'll check for normality now. The other two will be processed when we run the ANOVA test. To check for normality, we need to order a histogram with normal curve for systolic BP for each group. We'll begin with Group 1, the group that got drug A. Click Select Cases, click If Condition is Satisfied, and click If. In the dialog box, enter Group equals 1. Click Continue, click OK. Now that only the records for Group 1 are active, we can order a histogram with normal curve. Click Analyze, Descriptive Statistics, Frequencies. Move systolic BP to Variables, click Charts, and select Histogram with normal curve. Click Continue, click OK, and it'll process. The histogram for Group 1, drug A, meets the normality criteria. Now we'll repeat this process for Group 2, drug B. Click Select Cases, click If. In the dialog box, enter Group equals 2. Click Continue, and click OK. Now that only the records for Group 2 are active, we can order a histogram with normal curve. Click Analyze, Descriptive Statistics, Frequencies. Notice that systolic BP is still in variables. Since the Charts option hasn't been changed since our prior run, we don't need to revisit the Charts menu. Click OK, and it'll process. The histogram for Group 2, drug B, meets the normality criteria. We'll repeat this one more time to process Group 3, drug C. Click Select Cases, click If. In the dialog box, enter Group equals 3. Click Continue, and click OK. Now that only the records for Group 3 are active, we can order the histogram with normal curve. Click Analyze, Descriptive Statistics, Frequencies. Click OK, and it'll process. The histogram for Group 3, drug C, meets the normality criteria. Before we run the ANOVA test, we need to select all of the records. The simplest way to do this is to click on the filter $$ variable and press the delete key. To run the ANOVA test, click on Analyze, Compare Means, One-Way ANOVA. Move Systolic BP to Dependent List and move Group to Factor. Click Options and click Descriptive and Homogeneity of Variance Test. Click Continue. Now click on Post Hoc. The Post Hoc menu allows us to select how the pairs of groups will be compared to each other. Since each group has the same number of participants, we'll opt for the Tukey test. If the groups had had different ends, then we'd select the SIDAC test instead. Click Continue, click OK, and it'll process. We see that each group has an N of at least 30, hence the N quota is satisfied. We also see that the homogeneity of variance test returned a p-value of 0.656. Since this is greater than 0.05, this indicates that there is no statistically significant difference in the variances between the groups. Hence, the homogeneity of variance test is satisfied. Back to the descriptive table, notice that this table contains the means for each group. These figures will be useful when it comes to documenting the results. Finally, we see the results of the ANOVA test. The p-value is 0.003. Since this is less than or equal to 0.05, this tells us that at least one group statistically significantly outperformed another. To determine which group outperformed which, we'll look at the pairwise comparisons on the multiple comparisons table. The first pair we'll assess is drug A, with a mean of 120.37, and drug B, with a mean of 122.37. The p-value of 0.019 is less than or equal to 0.05, indicating that drug A statistically significantly outperformed drug B. The next comparison is drug A with a mean of 120.37 and drug C with a mean of 122.70. The p-value is 0.005. Since this is less than or equal to 0.05, this indicates that drug A statistically significantly outperformed drug C. The last pair of comparisons involves drug B with a mean of 122.37 and drug C with a mean of 122.70. This comparison produced a p-value of 0.891. Since this is greater than 0.05, this tells us that there is no statistically significant difference between drug B and drug C. This concludes this video.